Friends, there are new innovations happening almost every day when it comes to space exploration. And space exploration is not the final frontier. We have a long way to go, but it's definitely the next frontier. And when we talk about space exploration, I want to draw your attention to the middle school science that you have studied. So let me ask you, do you draw any equivalence with launching into space and throwing stone in the air? If yes, let me draw your attention to this slide, which talks about the science of parabola. And if you remember, this science of parabola basically gives you impression where you can actually send your rocks that you're throwing at an angle of 45 degrees, and just by throwing at 45 degrees you can have the maximum distance covered. However, if you throw them high, then there could be a chance that you can actually throw them high enough and they will get into orbit. So it is like throwing your rockets into space, and by virtue of sending them at the right speed, at the right angle, you can actually put them in orbit. But have you ever thought about just drawing the examples of throwing stones in the air and drawing a parabola through the atmosphere? Have you ever given a thought that what it takes to send a spacecraft into orbit? And that is the orbital velocity. And when you talk about orbital velocity, is basically the spacecraft which is being sent with the intention of not leaving the Earth gravity, but reach the space and remain there in a particular set orbit. And when you actually send a spacecraft in an orbit, you actually design this spacecraft with that intention, and at that height the spacecraft is supposed to do certain things. So you actually plan the whole thing, but the biggest obstacle is going against the gravity of the Earth, and that is where this formula comes in. This is a fairly standard formula, and this formula gives us the velocity required to reach certain orbit. So if you want to reach certain orbit, say example, you want to reach 100 kilometers above Earth or 300 kilometers above Earth, you know your objectives, and by applying this formula you can get the launch velocity required in order to reach that point in the orbit, because other three parameters are constant. If you look at the gravitational constant, it is a constant. We know this is a figure. If you want to know the mass of the Earth, it is again a constant, and also the radius of the planet, so that you can calculate the distance required from the surface of the Earth to the orbit. And so this will give you a orbit, the velocity required at which you have to throw your aircraft into the Earth's orbit. And then you can apply other scientific principles to come out with what is the size of the spacecraft, how much weight it has, and in order to carry that at this particular velocity so that it can reach that orbit, what is the kind of propulsions I would need, how much energy I need, and so on and so forth. Now this is with regard to sending your satellites and other spacecraft like space station components into orbit. And this formula never fails. It works on Moon, it works on Sun, it works on Venus, it works on anything in space, anything on Earth. This is a formula which is required to send objects into orbit of those planets or Earth. Now, what if you want to send the aircraft in the outer space? That means the spacecraft has to now totally get out of the clutches of the Earth and get into outer space. So for that, using the same formula, if you look at the speed that is required using the same formula, is 11.2 kilometers per second. This is a kind of velocity at which we have to launch the spacecraft and send into outer space. Now this is a lot of speed. I mean, if you look at this speed, it is mind-blowing. 11.2 kilometers per second is something which is unachievable. I mean, you can achieve something like 25,000 kilometers per hour, but 11.2 kilometers per second is it's very fast. So in using the today's launch technologies, the scientists basically cannot achieve this speed from ground level, but they ended up achieving this speed from the orbit. So they use the Earth orbit to increase the speed of the spacecraft, and eventually it will go out of the Earth's clutches. However, the same formula applies on Moon, and because the Moon is a much smaller object, the Moon escape velocity, as we call it, is 2.38 kilometers per second. Still very high, still quite high, but not as high as required to evade the gravity of the Earth completely. But if you look at the Sun is a huge object, and Sun is so large that it can accommodate a million Earth inside it. The amount of speed required is mind-blowing, 618 kilometers per second in order to escape the clutches of Sun. So you can imagine, if you get into too close to Sun, you will be completely sucked inside the Sun, and there is no way you can come out, because this kind of escape velocity you will not be able to generate unless you have the right skills and right technology. So the friends, actually, why I'm talking about this and why I started by giving you an example of throwing a stone, because when you are sending your spacecraft in orbit, you are actually throwing them in the very high trajectory, and when they reach the orbit, they want to start falling back on Earth, but when they are trying to fall back on Earth, the Earth is also moving, so they cannot fall back on Earth. So this is the meaning of orbit. So when you are on orbit, it is a motion of constant falling, but you will never reach Earth because you are in orbit. So for that, you can use this formula which I showed you. However, to escape, to venture out on the other planets, to escape completely from the clutches of gravity, or to go to Moon, you have to use a totally different type of aircraft or spacecraft which can take you there. It is a huge, if you look at the Apollo program, the rockets used were huge. I mean, they are really huge, and the initial velocity at which they are being launched is also very high, and they will eventually attain the escape velocity out in the outer space. So considering all that, the expense of sending these spacecraft into outer space is huge. The amount of energy, amount of material that you need to burn in order to create the thrust is also huge. So if you want to send large spacecraft, and if you want to live a dream of sending large spacecraft with a lot of crew, I think it's just a pipe dream if our technology does not improve. So there is an innovation which is happening in this area, and this innovation will basically, you can get rid of sending these large spacecraft, and we can get out of this conventional use of the hydrogen and other or any other propellant, which is very heavy, very expensive, and you need very large vehicles to launch them. So this company called Spin Launch, it's basically a startup. Right now they are doing testing, and they are coming out with a different mechanism, and this mechanism basically is similar to a catapult. So as the name suggests, the Spin Launch is basically a huge centrifuge. This round drum that you see in the background is a huge centrifuge which basically has an arm inside the centrifuge. And by the way, the size of the centrifuge is much bigger than the Statue of Liberty. So it's huge. By no means it's small, but the amount of energy which will be used here is going to be much less than what you will actually end up using by sending a spacecraft into using conventional method. So what it does is that it uses some sort of electric energy or some sort of kinetic energy to generate a spin inside this drum. There's a huge arm which basically to which the spacecraft is attached on one side, and then this arm starts rotating. And when it rotates many times the speed of sound. And as it continues to rotate, it generates a lot of speed, and the speed keeps increasing, and you can actually control the amount of speed required. So you will calculate using the same equation that we covered in the beginning. You will actually use the same equation to calculate how much spin is required at what speed, depending on the weight of the spacecraft that you want to launch. And once that parameter is attained, that means the spin is equal to the amount of speed required in the air to launch this spacecraft. The spacecraft is released and it will reach the orbit. Now this system will be much more less energy, it will consume less energy, and the promoters of this company, which is a startup, they are saying that it is going to be consuming 80% less energy as compared to a conventional rocket. And that is why this could be very effective method and very safe method, because the things are more predictable in this manner. I mean, if you compare the safety record of rockets, many things can go wrong because there are many moving parts within the launch vehicles. So if there are more moving parts, that means there is more chances of failure. Whereas in this one, you can attach the payload, rotate it, and then launch it. So the things can be very in a very controlled environment. You can predict most of the outcome. The weight of the payload that you want to launch in the space. So this way you continue to launch your spacecraft into space, and especially this may not be suitable for sending the livestock or crew to the space. I think the conventional method will be used to launch the crew, but a lot of these different components of the larger ship can be sent out into space, and they can be sent into orbit, where the crew can then go out and assemble them in order to make a huge spacecraft. Because when you're constructing a spacecraft on Earth, launching that spacecraft into space will require a lot of energy. So it's not practical. So this is a very innovative idea, and I thought when I read about it, I thought I'll talk about it today. This is a very, very innovative idea, less dangerous, and especially the components can be sent through this sort of catapult, which can be they can be constructed at many places on Earth. So it need not be on a launch pad or something like that. So these are very easy to use component. However, it requires a lot of R&D, a lot of testing is required. So I think they have started conducting tests, and they have launched certain things, certain payload to up to 10,000 feet so far successfully. And the company says that they will be conducting a lot of tests till 2030. The testing has already started. So I think that will take time. A lot of funding will be backing this sort of initiative, because this is going to reduce the launching into space by manyfold. So eventually the launch stations that we see today, the launching pads or launching rocket, will be the thing of the past, especially when we are sending the cargo or things like that, or components into space. They can be sent into space at very low cost, and therefore we see a competition emerging for SpaceX now, especially in the launching pad arena. And so after 2030, I think a lot of exciting things may be in store for us. A new sort of competition may be brewing up. Friends, this is something very exciting to me, and especially when it is related to innovation, especially in the area of space exploration. Do write in your comments, and if you have more information, you can share your knowledge with us, and we will read your messages in the next section of Akulmek Live. I'll say goodbye today, only to catch you in the next one.